everybody. I hope you're having a great day so far. Thank you all for joining today. My name is Nandita Joshi. I am a senior product security engineer at Zendesk. And today I'm going to be speaking about AI in the org, what product security needs to know. All right, so let's get started. So AI, or more specifically, generative AI in the organization, which is a subsection of AI, is the bit that specializes in text generation, image synthesis, code creation, and more such tasks. With the recent popularity of tools such as ChatGPT and DALL-E, it's really made it easier to harness the capabilities of Gen AI, and its use cases for simplifying tasks and boosting workflows are just so obvious and so many that it's no surprise that organizations are taking to it, and they're looking to adapt and adopt this technology and gain a competitive advantage. So as security engineers, what we really do care about with respect to this technology is ensuring that it's implemented securely. And to understand what that entails, what I'm going to start with today is a context, or provide a context in which talks about how you see generative AI in organizations at this point in time. And after that, we'll use that as a basis to go ahead, take an example use case of a chatbot agent, talk about the architecture diagram of very high level architecture diagram of what that chatbot agent could look like in terms of its implementation and interaction with different services, and then use that as a basis to sort of go over the different risks and threats that are introduced with Gen AI, the controls that we can put in place for secure Gen AI deployment. For anyone that's worked with AI security, I think you'd all agree that it kind of takes a village to ensure that your Gen AI models are deployed securely. So we'll then speak a little bit about the holistic approach to Gen AI security, or what are the different collaborations and cross-team collaborations that we should be considering when it comes to Gen AI deployments. And finally, then we conclude with takeaways from today's talk. So generative AI in the org. There are two ways that you would typically see or interact with Gen AI in your organization. First case would be as consumers, where you are using Gen AI-powered productivity tools to boost your performance in some form. And the second that I can think of is as producers, where you are developers that are working on creating Gen AI-based features. So if you have ever used automatically generated meeting summaries, code assistant tools, personalized chatbot interactions, or even retrieving context-aware recommendations from a large number of data sources and making sense of it, you've likely interacted with generative AI. In terms of their security, while the risk that is introduced by these AI implementations largely remains the same, the severity of the risk varies fairly depending on the specific use case of your generative AI tool. So that's not something you decide based on whether your tool is deployed internally or externally. In both cases, we sort of need to consider a lot of other factors that go into describing or assessing the risk posture with this tool. So some of the things we need to be considering are, take for example, the sensitivity level of the data that you input and send over to your AI model. Or you also need to be thinking about where your AI model is hosted and what's the kind of data that it trains on. And so then taking the first point and the second point together, if you have an AI model that's sort of an on-prem deployment, you have greater control over the kind of data that's being sent to it. And in that case, you might be able to send sensitive data over to this deployment when compared to a deployment that's more of a SaaS-based solution. So next, what we're going to look into now is once a specific use case of your generative AI powered productivity tool, take which is a chatbot agent that's used for personalized interactions. So what we're seeing on the screen up here, this little diagram on the left-hand side, it's basically a very high-level architecture diagram of what your chatbot agent application might look like. It starts with the end user interface box. What that box might look like is a web or mobile application through which an end user interacts with the chatbot. Moving on to the center, what we have is the enterprise app services that interact with some sort of customer data. And for the sake of this diagram, let's consider that the enterprise app services basically represents this entire entity that involves everything from your API gateways to all the different microservices that are needed to communicate with the end user interface, to communicate with your LLM production services that, all these different services that sort of take your conversation history, save your conversation data, route chats, everything. All of that is just the enterprise app services. And moving on to the right, then what we have is at the bottom, we have the training data set and processing, which basically consists of your two training database and a fine-tuning database. And then up on top of that, you see the LLM production services. So these LLM production services, these are basically services that we can consider what are called by the enterprise app service. And based on the input that is retrieved by these services, based on the training data that they have access to, and the model that that's implemented, the LLM automation would basically perform the necessary tasks such as text generation, creating your personalized user response, and then send it over to the end user. So on a high level, so the data flow diagram that we're seeing here is your end user interacts via the chatbot interface. Then you have the enterprise app that service that receives this user input. It processes it in some form and sends it over to the LLM production services. Then your LLM model interprets the request, trains on this. It's trained on the training data set. It's possibly trained also using the fine-tuning data to sort of continue training its data set, and then it basically understands and generates a response using a combination of all the production services and data sets that we see here. And this is then sent through the enterprise app services back to your end user interface. So before I get into assessing the risks in this environment, there are some design considerations that we always need to be thinking about when it comes to this. So some are, what is the chatbot's purpose and goal? Now, this is something that's important to know because you want to ensure that you have very clearly determined what the chatbot should and should not be able to do, because that sort of helps you identify and detect when the chatbot behaves abnormally. The next thing that needs to be considered is the LLM production service self-hosted or a SaaS product? And now again, this again comes to determining how comfortable you would be sending the kind of data, how much control you have over the Gen AI implementation in your environment. How is the model trained? Is it open sourced? Does it store or process any customer data, user input? Now your models can be, they could be trained, they could be taking open source data, or they could be completely trained on your internal data that you control. And that greatly varies or changes the kind of response you're going to receive from your chatbot. Does the LLM have any plugins enabled? In the case of this architecture diagram, there isn't any, but it could be possible that you have LLMs that have plugins which they sort of autonomously interact with when they receive requests from your application service. And the fifth most important design consideration that should be thought about is access control enforced, not just in your upstream system calls, but also in your downstream system calls. So moving on to risks that are introduced with generative AI. Um, I'm quickly going to go over what are the different risks and what's the bad thing that can happen with these risks. Starting with the first one, where um, it's just really a note mostly that says that LLMs are an interesting case where both user input and LLM output are untrusted. Now, this is really interesting because, um, in your typical web application, you know that user input is untrusted. What's happening here is that because of the nature of generative AI, this user input that's supplied is conversational in nature. And because of that, it could be that the user input that's supplied is intentionally as well as unintentionally malformed or just unclear, vague, incomplete, or inaccurate. And similarly, due to the nature of how LLMs work, the output that you receive is also going to be untrusted because it's going to work with this possibly vague, ambiguous input data, and then it's going to generate some sort of content which could exhibit uh, depending on the kind of response it's providing, it could exhibit bias from training data. It could lead to propagation of misinformation. It could lead to generating indesirable content. So we really have to keep in mind that both are untrusted. The second risk that's introduced with Gen AI, again, we're talking about all this on the end user interface. So prompt injection and model theft. And these are generally of greater concern in external facing applications simply because you have users that are more motivated to get access to your internal systems. And this is just another vector for them to do that. The third is insecure transmission of data and or API access key, which can leak sensitive or proprietary information. Now, this comes from your very simple, transmitting data unencrypted in clear text or improper management of your API access key, which can lead to sensitive or proprietary information disclosure. Bad training data can result in unreliable generated content. Now, this can be caused by pre-existing polluted data or injected poisoned data, and this is called training data poisoning, where if you think about it, LLMs begin with raw text, and then this raw text has a whole broad range of content that it consists of. And now, basically, this trained data is what is used or what they rely on to sort of make sense of it, identify patterns, and then generate a response for us. So training data poisoning basically refers to the manipulation of your training data or your fine-tuning data that you see here, and this can lead to quite serious implications, such as introducing backdoors and biases that compromise your model's security. Compromised training data, ML models, plugins, and deployment platforms can lead to system failures. What we're talking about here is supply chain manipulation. Now, with your typical supply chain attacks, what we are really focused on are software components. But with ML, this is extended to the training data that's supplied, the pre-trained models, as well as the LLM plugin extensions, if there are any. So, for example, if you use crowdsourced data for training, that can lead to vulnerable system components. One such example was a recent vulnerability that was introduced in a collaboration platform called Hugging Face. Hugging Face is a platform that helps users host pre-trained ML models and datasets, but it had a conversion service and a conversion service bot, which was compromised. And what that basically led to was it allowed attackers to hijack user submitted language models. And that eventually kind of led to allowing attackers to compromise the system that was hosting it. Moving on to number 6 in the diagram here, if user input is logged, stored, or used to train the LLM model, I think it's pretty descriptive here. It's at a risk of data leakage and exfiltration, right? Number 7 is hallucinations. Hallucinations is where your AI is producing output that's just unexpected and unreliable. And this usually stems from over reliance on the AI ML implementation. And what that means is that it's a situation where you end up providing the AI ML model with excessive agency. That is the degree of decision making that an LLM developer allows it to perform is excessive. So this can one of the things this can look like is say for example a trial plugin that your LLM model worked with or implemented or used at some point in time, and then it was later deprecated, but it wasn't removed, so it still has access to this plugin. Or another example for this could be generally relying on excessive autonomy that is granted to an LLM-based app, which basically allows it to perform restricted actions or sensitive actions that it shouldn't be performing. Number 8 is theft of proprietary models can result in a shadow model assisting with data exfiltration. This is also called as model theft. And what model theft basically involves is unauthorized access to your, or even copying or exfiltration of your proprietary LLM model. Now, this is something that you would typically see at more of a APT level, but this has grave consequences, right? This can lead to reputation damage. This can lead to loss of proprietary data. This can lead to financial loss, and it can also lead to unauthorized use of the model to access sensitive, unauthorized information. And what I mean by that is that if someone has access to an LLM model, they can make a large number of requests to the model to sort of learn how it works. And, it could be possible that they gain access to sensitive information through that knowledge. The ninth thing we're going to be speaking that's here is resource intensive operations can lead to denial of service and high resource costs simply because of the nature of AI ML implementations being resource intensive. And it just so happens that if you have insufficient rate limiting on a call and that call is resource heavy, then you're basically going to end up in a situation where you have a denial of service. The final point up here, which is a risk introduced with Gen AI, is really basically insufficient validation, sanitization, and handling of output, which can result in your typical AppSec vulnerabilities. So the point here being that you still have all of your AppSec vulns, right? And with the introduction of AI, you're only sort of expanding on that attack surface and adding in more of these AI ML specific risks in addition to the project issues that we're always going to be thinking about. So controls for secure Gen AI deployment, input validation and output encoding. Now in this case, it's a little different because you kind of have to ensure that your user input adheres to certain limits and filters out any malicious content. This would apply typically on your input, but there are cases where you might also need to implement filters on the output that's being returned to the user to ensure that there's no sensitive information or PII kind of information that remains in your output that's being sent back. You also want to encode model output back to the users and follow your general AppSec recommendations from just the same as the OWASP guidelines that we have. The second is preventing prompt injection. I don't know if I really got to speak a little. I don't know if I spoke much about prompt injection before, but very quickly, it's very similar to your injection attacks, where the whole reason it happens is because you're providing this user input, and it's not your system cannot distinguish between user input and the rest of the query. So basically, preventing prompt injection is going to be what you want to do is separate external content from user prompts. And it sounds really difficult because you're working with natural language, and that's a hard thing to do. But then you have one example of doing this is ChatML for Open API calls. And basically what that does is it makes an explicit call to the model and lets it know the source of each piece of text that it receives. And how it does this is by using headers where it kind of provides descriptions about the origin of the text and attaches it to the data. And the next few controls we have on preventing prompt injection are your privilege escalation. So you want to ensure there's adequate privilege control on LLM access to backend systems. You want to ensure that you have human approval required on privileged actions. So this is the part where you want to make you're sort of not over relying on the AI system to perform sensitive things. Encrypting all data at rest and in transit, ensuring secure secrets management practices, preventing training data poisoning. This is something you would, so the whole point of this is you want to ensure that your fine-tuning data, your testing data are not tampered with. You want to verify the supply chain of this training data and ensure that there's sandboxing through network controls to prevent scraping from unintended data sources. Securing the supply chain. What we want to focus on here is protecting the integrity, again, of our training data and our pre-trained models, in addition to the deployment platforms. And one way to do it is using model and code signing when using external models and suppliers. And of course, if you're using third-party implementations, you want to use trusted, vetted data sources and suppliers that respect opt-out policies. Hallucinations, you want to limit the attack surface. You want to remove over-reliance and excessive privileges provided to your AI implementation. And model theft, you want to sort of have adequate monitoring and auditing, audit access logs and activities related to LLM model repositories, so you know what's going on. You have continuous monitoring on them, have strong access controls and authentication mechanisms to limit access to your LLM model repositories. So now we've spoken about, what is a little bit about what Gen AI kind of looks like and system architecture diagram on a high level, some of the risks associated with it, some of the mitigations, but all of that was from your prod side of things. But securing or deploying Gen AI securely requires a holistic approach because it involves a whole lot of things. You have a feature, you're examining the feature in its entirety, you are considering its purpose, you're considering the intended users and data management. And this really requires a collaboration between many different specialized teams to ensure it's all happening the right way. So some of the teams that I've mentioned up here are compliance, who help you adhere to regulatory requirements, ensuring that you're meeting all your industry regulations, privacy and legal, that ensure that your data is secure, you're maintaining user trust, and you're also sort of monitoring the ethical use of AI and looking for a risk of bias and sort of staying cognizant of data ownership and liability. You have your vendor security that you would work with when you need to vet third-party vendors that provide AI solutions. You want to make sure that they're adhering to their security best practices, they have the right certifications, security practices. And you also want to provide comprehensive documentation to facilitate transparency, accountability, and auditability with respect to these Gen AI system deployments. So that's my talk, and these are some of my key takeaways for you today, which is AI has the potential to fundamentally change how we interact with the world around us. It's here, and it's at least for now, it's here to stay, right? So we have to start to secure it, and the right thing to do would be to start securing early to avoid heavy costs of retraining and re-implementing your models. When you think about things like pollution of your AI models and tampering with your data sets and things of that sort. You want to perform context-aware risk prioritization and keep in mind that application security best practices continue to apply, and we don't need sort of working with an expanded threat landscape. And fair and secure use of AI requires a comprehensive cross-functional approach to AI deployments. These are some of the references that I use for my talk. It was top 10, the NIST documentation, the DevCon AI Village blog, and the CSA blog. And yep, if you're still here, a big thank you. And if you need to reach me, you can reach out to me on LinkedIn. If there are any questions, comments, feedback, I can take that now. All right. I don't see anything. So yeah, thank you all for coming, and I hope you learned something today. Bye.